Hello everyone, good evening. So welcome to join our monthly APOD session. So this is our first APOD session in 2024. Yeah. So here we have Dr. Chong, the president of the Astronomy Society Penang, and Marcus, and also me. So our chair will present the January APOD. Yeah. So I pass to Dr. Chong to have first APOD. Yeah.
Thank you very much for our host for the meeting, our Miss Jiu Boon Wei, yeah. And then
Thank
she's
you,
of
Dr.
course
Chong.
a committee member of our Astronomical Society of Penang. And then of course our another member presenter is Marcus Cheng, all right. And both Boon Wei, Marcus, and me, we are in Penang right now. And of course, we would like to thank very much our member, Mr. Lai Hong Jun, who is now in Beijing. He was the one who selected the pictures for us to present. So thanks to Mr. Lai. And of course, we would like also to thank our member, Mr. Rayan Al-Qadri, because Rayan now is no more presenting because he's on the way to Australia to pursue his further studies in the University of Sydney. But we hope that even in Sydney, he has a time, he can still help us to present online the airport pictures. So this is the first airport presentation of 2024, like what Boon Wei say, and we present our airport on the last Sunday of every month. So 20th of January. Okay. So let me share my screen now. Can see my screen, Boon Wei, Marcus?
Yeah, can see.
Okay. Okay. So as well picture of the day archive. Now remember recently, Marcus and Boon Wei, the board of the scientists in airport, Professor Nemirov and what they have a live presentation on the 9th of January. You should go again watch it. Interesting. So basically, to me, the best pictures in astronomy is actually airport. As well picture of the day by NASA, where they pick the best pictures in astronomy or astronomy related topics. It need not be exactly dealing with astronomy, even some weather phenomena or the new technique of astrophotography is in there. So if for this selection given by Lai, I present my first picture, January 28, 2024. So this is the first one. Pluto in true color. All right. Now this is a bit big. I will reduce the size of the picture. Okay. So this is Pluto in true color. Now remember, how can Pluto be so bright as seen from the Earth? Good comment. Actually, if from the Earth you look at Pluto with a telescope, it's just a point. But even if you enlarge it, it's actually quite dim. Right? But from Pluto, you look at the sun. For example, from the Earth, you look at the sun, it's magnitude minus 26, very bright. But from Pluto, look at the sun will be magnitude minus 19. So on the surface of Pluto, the sun is just like a very bright star. So if you fly by Pluto, you will observe that the surface of Pluto will not be so bright as this. But of course, during the flyby of the New Horizons mission on the 14th of July 2015, we followed that mission. Of course, after flying by, they process it and they enhance it. But important thing is, if this is the real true color of Pluto, this is how it looks like. All right. Now Pluto is a very small planet, right? So sorry, I made a mistake. Pluto is now called a dwarf planet. Right? It's about 2,000 kilometers in diameter. Earth's diameter is 12,000 kilometers, much bigger than Pluto. And here you have the Regio Tombo. The Regio is a Latin name for a region. Tombo is the discoverer of Pluto about 100 years ago, 1930. So Regio Pluto. So basically, it's frozen nitrogen. Nitrogen on the Earth is a gas. If you cool it, it becomes a liquid. You cool it, some it becomes a solid. So it's solid nitrogen. And on the other part here, it's basically methane. And then because Pluto doesn't have an atmosphere, so the UV light from the sun will change the color of the methane to this chocolate color. So this is the what they call the true colors of Pluto, and it's what the real color of Pluto. Okay, with a big heart over there. All right, and of course remember the flyby was in 14 July, Americans Independence Day. 2015. And of course, this is by NASA. Everyone knows NASA. JHUAPL, John Hopkins University Applied Physics Laboratory. Remember, in the University of Baltimore, which is in the city of Baltimore, near to Washington, D.C., there's a John Hopkins University. And in John Hopkins University, you have what? STSCI, Space Telescope Science Institute, where the Hubble Space Telescope and James Webb Telescope people are based. But also next to it, you have the James Applied Physics Laboratory, where this is where I took this picture of Pluto during the flyby. All right, so this was great. And the processor is our Alex Parker, the one of the NASA scientists who is very good in processing the picture. All right, so this is our Pluto in true color. All right, but if you want to fly by Pluto, all right, you look at the surface of Pluto, it won't be so bright. It has been enhanced. All right, but it is has been enhanced. This is how Pluto will look like. Okay, we come to the next picture, January the 25th. I make it bigger so we can read the font here. Now, of course, the wording is in Finnish, in Finland, but never mind. Let me imagine I pronounce it in Finland. Google pronunciation. JY is not, Malaysia is called G, no. JY becomes Y. So it's in Finnish, so Jyväskylä, in the sky. So basically it's a kind of reflection in the sky by our Harry Kiskinen. Now, many of the people who contribute to APOD are not astrophotographer, not astronomer. They're just normal photographer. So basically this is a normal photographer. And what he does is, there's a place called Jyväskylä near to the capital city of Helsinki in Finland. And he took a picture of the night sky and he saw these patterns in the sky. Basically it's this. This is the street lights from the earth scattered up into the atmosphere. And in the atmosphere, because it's very cold, there are a lot of ice crystals. So those ice crystals will scatter the street light back to the earth. So I repeat, the street lights on the earth in this place called Jyväskylä in Finland reflected up, and there are ice crystals in the sky, and the ice crystal reflect the light back to the earth. And on the earth, you look at it. This is the street map of the sky at night, where it's very cold. All right. So this is it, and this is very interesting. All right. So many of all kinds of interesting astronomic phenomena we can find. All right. So that's it. So now we go to the next one, January the 24th, Earth and Moon from Beyond. All right. So the top one is the Earth, the Moon. Of course, when you see the Earth by right should be much bigger than the Moon. But now the Earth is smaller, the Moon is bigger. That means the Earth is actually much further away. The Moon here is much closer. And I reach here, and it's our Artemis 1. Remember, in what they call in 2022, the Americans sent the Artemis 1 mission in November, launched, and then it landed in December 2022. All right. So basically, the Americans are testing their main spacecraft to go to the moon. But this is an unmanned spacecraft. So after launching from the Earth, the Artemis 1 spacecraft, it is called Orion spacecraft, flew by the moon and orbited the moon. And as it was orbiting the moon, it took a picture of the pair, which is the moon and the Earth, all in one shot. Okay, Earth and the moon in one shot, taken from our Orion spacecraft in the Artemis 1 mission. Now remember, next year, the Americans will have another test of the Artemis 2 mission. And in 2026, they are going to launch a manned program, the NASA, to go to the moon. And on it, you will have one woman astronaut also, plus some of the male astronauts, right, from the United States. So this is our Earth and Moon from Beyond, taken by our Orion spacecraft of the Artemis 1 mission in 2022. And so you have this. So it's very exciting. And of course, you know that even the Russians and the Chinese have their space program. They also want to go to the moon and set up a permanent moon base, just like what the Americans are doing also. Okay, so this is what they call processed by our Andy Saunders. Okay, Now, Andy Saunders originally is from the UK, and he's expert in processing many of the NASA images. Expert on processing digital pictures by NASA, Mr. Andy Saunders from the UK. Okay, so I pass now to the next airport pictures by Boon Wei. Okay, so I share my screen.
Thank you, Dr. Chong.
Sure.
Hello, everyone. Thank you, Dr. Chong.
Yeah.
So, hello, everyone. So, actually, I long time did not show up in the APOD section. So, hope all is doing well. The first APOD I would like to present. Let me share my screen first. Entire screen. So, Dr. Chong can see my screen now?
Yes, can see now.
Yeah. Okay. So the first APOD I would like to present
nice.
is on the 13th of January. Yeah, this is the sun caption there.
Wonderful.
The circling the sun. So actually this is the halo of the sun. So the picture is taken by Rado. Yeah, so he is a hobby photographer for the astrophotography and the landscape and nightscape. So this picture was taken actually from the explanation there. This was taken when at the closest distance to the sun. So we all know that the orbitary of the Earth, the sun is actually in the eclipse. So this is when the Earth is at the nearest to the sun. So it's on January 2nd of January. So this picture is taken on 2nd of January at 1 o'clock UTC at the somewhere the countryside near Germany, the Herolfstadt, Germany. So this is about like 3 million miles closer to the sun at the perihelion. We call this nearest distance as the perihelion. And then actually the furthest point is called as aphelion. Is on last July, 6th of July. So basically the nearest distance and the distance from the sun is actually not really determine the season. I should put it smaller. Sorry.
Can see. Wonderful.
Okay. So the distance from the sun is not really determine the season and also not determine the size of the sun halo. But this one is showing the sun is hidden behind, just right hidden behind a tall tree trunk. And then because it's a winter in Germany now, so the atmosphere has a water and the ice crystal is drifting high on the atmosphere. So when the sunlight is shine on the ice crystal, was refracted away and then form a beautiful ice halo. And this halo, if you count from here to here, is actually 22-degree angular diameter. So this is a very very nice picture. So that's all for the explanation for the 13th of January. Okay, so we'll go to the next one is the 12th of January. Another beautiful nightscape picture taken by Michael Love from the TWAN Tier Observatory. So this is also taken from Germany. You can see there's a castle and Germany was very famous with the castle, the beautiful castles. And this is taken in the city of Seeberg, Seeberg in Rhineland-Palatinate, the western of the Germany. And this picture is taken before the sunrise. It was taken on the 9th of January. The moon is actually just rise at this is east before the sunrise, and from this picture can also see Venus over here and the Mercury over here. So Venus is very bright. So now if you want to see, maybe you can also see it happen near to the sunrise. Yeah, normally it's happen near to the sunrise or the sunset. Yeah, also Mercury. So okay, so this foreground, yeah, we know already saying this old castle was actually built from the 10th century. Yeah, very old castle. So to tonight actually the moon also will rise at 9:29 p.m. in Malaysia time. Now is almost full moon and starting to discern a bit. And actually you see now this new moon rise um when the sunrise, before sunrise, right? Then now the moonrise is almost in the night time, because actually the moonrise time is different time at when it's a different phase. Yeah, based on the lunar cycle. So I have a diagram actually to check the time. So okay, you can see here.
Wow.
Yeah, yeah. Actually I pull from the textbook.
Yeah.
Yeah. Okay, so this is also the, yeah, this you can see this is the lunar phase. And yeah, near to the new moon, and yeah, near to the new moon and waning crescent is actually rise during the dawn and then set when the sun set. So almost the same time when the sun rise and the sun set, because the earth will almost blocking it. Then the full moon is actually rise when the sun set and then set when the down. So that's why we celebrate the Mooncake Festival in night, not in the in the morning.
Yes.
Yeah. Okay. So yeah, that's all for the explanation in 12th of January. Okay. So go to my next one is on 11th of January. Yeah. Okay. So this is the January 11 January, and this is the picture called quadrantics of the north. The meteor shower that happened in January is annual quadrantic in always happen on the January. And this picture is taken by Bom Sok Yum. Mr. Yong is actually a South Korean astronomer. So this is the the meteor shower that happened in northern hemisphere. Yeah. Um, so for the information, the quadrant is always the radiant is always lies not far from the Big Dipper. Yeah, and then is almost near at the boundary of the modern constellation Bootes and Draco. And from this picture, can actually see is the the yeah, the Big Dipper handle stars are near to the upper right corner in this frame, and then with the meteor shower is just right below here. Okay, so the North Star Polaris is also toward to the top left, and the this is actually a composite image lah. Is record when the shower peak is on 4th of January from Jiangsu, Korean, South Korea. Yeah. The quadratic peak usually can actually produce up to 100 to 120 shooting stars per hour. But I think I remember we want to observe this, but it's quite cloudy in Penang that night, if I'm not mistaken. Yeah. Yeah. Okay. So that's all from me today. Yeah. So I will pass to Marcus next. Thank you.
Thank you, Boon Wei. Yeah.
Okay, let me share my screen.
Hmm.
Wait, and let me adjust the recording so it also record what I'm sharing.
Hmm.
Okay, wait. I'm going to
Please
share
mention the date, Marcus, your first picture.
Yeah,
Which date?
wait, let me share my screen first.
Okay. Yeah, can I see your screen? Mention the date.
Let me adjust my recording.
Your picture is not in the center. Bring it to the center.
Okay, so my first I will start with the January 18, 2024 APOD, and this picture is taken by was taken by a person called Ralph Roner. This is his Instagram over here. He's actually a pilot and an astrophotographer. So this picture was actually taken from an airplane when flying over in the sky. So this is a picture of aurora borealis, and for those who don't know, who don't know what it is. It's basically what we would refer to as northern lights. It's when solar wind. It's when like the solar wind produced by the sun hits the earth, and our magnetic field protects us from like the solar wind, and so it pushes like the solar wind to like the north and the south poles, and the effect it creates is something that looks like this, and which is what we call the aurora borealis. um so you can also, but not only that, you can see here, you can also see the Milky Way. You can also see the Milky Way galaxy. Let me zoom in for it. Let me zoom in. You can see the Milky Way galaxy over here in the background, and you can also see the Andromeda galaxy over here, I believe. I believe this is the Andromeda galaxy that you can see in the top corner.
Yeah.
So that's for January 18. Now I'll move to January 7th APOD.
Wow.
So the January 7th APOD is the Cat's Eye Nebula. So this is actually a planetary nebula, and it is believed that the star in the center is a dying star that is quite similar to our sun. Um, and this might be what our solar system looks like in 5 billion years when our sun starts dying. So the as you can see, the shells over here is believed, like the outer shells over here is believed to have been produced by like material released by the star, but it's still currently unknown what why like the internal structures here exist. You can see there's not only the outer shells, there's also things like inside. There's also inner structures inside, like within the shells, and it's actually unclear why these exist for now. and and the Cat's Eye Nebula is actually located over here in the Draco constellation. So this is exactly where it's located at. It's a part of the Draco constellation. So yeah, and that's for the January 7th APOD. And now I'll move on. Oh yeah, I forgot to mention that this was taken the optical image for this was taken by the Hubble Space Telescope, but the X-ray version was actually taken by the Chandra X-ray telescope, and these two were combined together to form this image. And now, for my final APOD, which is the January 2nd, 2024 APOD. So this is
Wonderful for you.
actually the most beautiful picture for me. This was taken just late December 2023 by this person called Steven Maddow over here. You can see over here. This is his Instagram profile. This was actually a let me zoom out. Let me zoom in. This was actually a Falcon Heavy launch early last year. I believe it was this launch over here. I'm not very sure whether it was this one or not, but the description here says it was taken last week. And since this was posted on January 2nd, I think this is around late December, so it should be this one over here. But I'm not 100% sure if it was this launch. But this, as you can see over here, let me zoom out. There is this rippling effect at the bottom of the moon. This effect exists because the rocket, the air around the air generated by the rocket is like, the heat generated by the rocket is like really really hot, and it is reflecting and it is deflecting the moonlight, but it's not deflecting it as it's deflecting it less strongly than the cooler air around it, and therefore it creates like this rippling effect over here. Like, you can actually see like a sort of similar version of it when you, for example, when there's like a smoke coming out of something, like a smoke coming out of fire, you can see the rippling effect behind the smoke of the objects behind the smoke. Next time you see a fire, you should try to observe it. Or like in movies, in movies there's also this faint rippling effect whenever the movie is showing something that's behind the fire. I didn't really explain it like very well, but you should go and see next time you see anything that's really hot or on fire. You can see there will be this rippling effect coming out of it, generated out of it. So yeah, that's all my APOD for today. I'll pass it on back to Dr. Chong.
Thanks, Marcus. So I'll share my screen for 23rd of January. Okay, the 23rd of January, deep nebulas from the Seagull Nebula to California Nebula. Now, I would say that this picture, of course, okay, the title is Deep Nebula, means far away into space, further than the solar system, from Seagull Nebula to California Nebula. But to me, I would say that this guy is crazy, Alistair Simon. He's an American amateur astronomer who has his own observatory called Woodlands Observatory in America. So basically, he must have gone to Arizona, a dark location, and he took 28 different pictures of the universe, 28 different pictures, and the total time taken was 800 hours. That means for 33 days, you add up. Why? Because most of the nebulae or nebulas are very dim. That means you have to do, let's say, this nebula, you take for, say 5 minutes. Tonight, you take for, say, 10 times, 15 minutes. Okay, 1 hour. And then you keep on taking the same nebula for the next day. And then maybe after, say, about a few days, you got a picture of the nebula, stacked enough, bright enough. And then you do another nebula. So altogether, 800 hours, 33 days. And there you can see all the names of those objects. So I'll read out first. Later on, I'll show you one by one. Amazing, Okay. So you have the Pleiades star cluster here, Barnard's Loop, Horsehead Nebula, Orion Nebula, Rosette Nebula, Cone Nebula. When I say nebula, I hope you know in which constellation. Rigel Star, Jellyfish Nebula, Monkey Head Nebula, Flaming Star Nebula, Tadpole Nebula, Aldebaran Star, Siemens 147 object, Seagull Nebula, California Nebula, but all in one. That means, imagine he took here Barnard's Loop, which is Orion, this object, one picture, but he took another object, Bellatrix here, and he made sure that this picture here with Barnard's Loop and Bellatrix are bordered to each other. So when he joined them, and this one image and this another image, he joined them, it's as if it's the whole sky. And definitely also all the border with all the other objects all joined into one whole. So basically, you have a wide angle camera. You look at the sky from Arizona, it will look like this. Incredible, all right? Now, the problem is when I move out, the thing disappear. So let's say here also you have an annotated image version, meaning you have the image itself, you can even print it, and where you can actually see the names of those objects. So here you have a SH2232 object, Flaming Star Nebula, California Nebula, right? Pleiades star cluster is, in other words, the border of one object and the other object are touching each other, and it join the whole sky together. Okay, Siemens 147 project, Elnut Star, Jellyfish Nebula. If I were to enlarge the Jellyfish Nebula, see how good is the imaging. Let's see, enlarge, not bad. Look at the jellyfish. See, very good. Even quite a high magnification, no? So now even a high magnification is still good. So I reduce the size now. So here you have a panoramic view, right? So you have SH2262, Cone Nebula, Betelgeuse Star, Orion, SH2262, Bellatrix Star. Now remember, in the Orion constellation, most of the star names are from Arabic, like Betelgeuse, Bellatrix. No, Betelgeuse, Saif, Rigel, Anita, Anila, Mintaka are Arabic. But Bellatrix is Greek. Huh? Then you have Barnard's Loop, Horsehead Nebula, Orion Nebula, Witchhead Nebula, all right? And the Witchhead Nebula is lighted up because of the star Rigel. The star Rigel will emit light, is reflected off the Witchhead Nebula. So Witchhead Nebula is a reflection nebula. And you have the star Saif in what do they call this? Orion Nebula, Orion constellation, and Siga Nebula, and so on. Then Rosette Nebula, Cone Nebula. So this is wonderful, no? So this is a what they call picture of 28 segments of the sky taken all together 800 hours, all right, 30 over days, and joined together as one by Alistair Seaman, right? This guy is really fantastic, all right? From somewhere in a dark location in Arizona, the United States. Okay, so I go to the next what they call airport picture, which is the 22nd of January. Okay, shadows of moon and mountain. Now, okay, this picture doesn't look that I would say at first glance it doesn't look that great, but after when you look at the explanation, you say this is great. Taken by our Senora Enzo Massa Nison, what they call photographer from Italy. Now, many of the pictures contributed to this airport are not astrophotographer. They are normal photographer, landscape photographer, whatever photographer, nature photographer. But at night, they point in the sky, they take. Okay, so this guy went to this place called the mountain called Griboli. Okay, so basically it's on the border of northern Italy and France. All right, there's a place called Mount called Gribola, and then on this is the top of the mountain, very high mountain, you know, 4,000 meters high, 12,000 feet high, and then you have the quarter moon and this. So basically, you see, he found the exact time to get the quarter moon in the sky. That means the sun is on the right side to light up the moon on the right side, quarter moon, and also the sunlight at the same time also will light up the right side of the mountain. And he have to travel left and right, must be on a highway or somewhere, such that the terminator line of the moon and the terminator line of the mountain align together. Right? So these are shadows of the moon, mountain, and moon. This is it's quite a common picture, but the timing is important. All right. So this is really great. Shadows of the mountain and the moon by our Mr. Enzo Massa Nison from northern Italy. All right. This is great. So luck comes. So in other words, when you see the opportunity, you see the moon there, and then you see quarter moon, and you have I don't want to use the word quarter mountain. You see this terminator line, and you move along the highway until this terminator line on the mountain and moon just align together. And in Malaysia, we'll say lah, ngam ngam. Okay, so we go to the next one, which is the 21st of January. This one. Okay, so I read here the Upper Michigan Blizzard of 1938. But this one can be accepted as an airport picture, no? By our Bill Brinkman and courtesy Paolo Rocco. Right? So basically, this is guy Bill Brinkman. He looked at the history of this place, and actually, Paola Rocco is the owner of a Sumi restaurant. It's a restaurant in Michigan. Remember, if you know the geography of USA, Michigan is in the state bordering with Canada. So in winter, it's very, very cold. So what happened is nearly 100 years ago, in 1938, the winter got a blizzard, strong wind, such that after the blizzard, the snow is from the ground level up to the top of this pole, you know, utility pole that carry the electricity. Very high, you know. I think maybe even 20 feet high. So that was it. So you have that year was very cold, blizzard, snowfall in winter in Michigan outside the restaurant by Paola Rocco, and then you see the snowfall so high. Of course, below there you don't see people, but you may say, what happened to the people there? Of course, maybe at this location the snow was piled very high, 20 feet high. But other parts of Michigan, I'm sure they have the plow, all right, they will plow the highway to remove all the snow such that traffic can move. Because in 1938, already got Model T Ford car in America. But in this location, the snow was so high that the road was buried under the snow. Okay, so this is the Upper Michigan blizzard of 1938, 22nd of January, no, 21st of January. We go to the next airport, 20th of January. Now, this is of course related to just now our what you call Marcus got this the moon rocket in front of the moon, but this is a bit different. This is a Falcon Heavy boost back burn. So what is this? Now, recently you have the Falcon Heavy, which was launched from Kennedy Space Flight Center, and there was a normal photographer near Florida, Dennis Huff. Now, I was in Cape Kennedy before many years ago. Just outside Cape Kennedy Space Center, you have a long beach, So during any important launch, thousands of people will be on the beach looking at the rocket launcher, and when the rocket goes up, people can see. So basically, you know that the Falcon Heavy is a heavy booster of this Falcon X SpaceX company. The rocket is Falcon X. So basically, when you launch up, you have at the what do you call the bottom stage, you have the core stage and two solid state booster. So when it goes up, of course, the upper stage will inject the payload into Earth's orbit. But then the bottom part, you have the core stage, which will fall down and damage, not recovered. But then you have the two solid stage strap-on booster will fall off, and there you are, it comes down. So now up there, the booster has already inserted the payload into Earth's orbit. But then later on, you have the two solid state booster will fall off from the core stage, and you fall down one side, this side, the two booster come down. But this doesn't mean that it's going up again. It just come down and actually going closer to the place where near Cape Kennedy Launch Center, where another launch pad is ready for the two booster stage to land back on the Earth. So this is the part. So number, it goes up, the two booster stage will detach from the core stage, come down and fly. So this part is coming down vertically, but this part is like flying horizontally over the Earth's surface. And then later on, they will land on the Earth's surface and be reused again. So the two booster stages are reused again for future flight by SpaceX, but the core stage will not be used, damaged already, all right? So this is a Falcon Heavy boost back burn, okay, by the photographer Dennis Huff. He was lucky, he was there, and he took this picture, or maybe it's a video, and you can see the whole time lapse there, okay? So Falcon Heavy launch from Kennedy Space Flight Center. So the next one will be 15th of January. No? This 15th of January. Okay, well, nice. I repeat, Star Cluster IC348 from the Webb. Webb means from James Webb Space Telescope. And because when you see from James Webb Space Telescope, so you know infrared. Remember, Webb is from infrared. So from now onwards, we don't say James Webb Space Telescope. We don't say JWST. We say Webb. Whereas from this Hubble, we say Hubble. So from this picture, what is the proof that it's Webb? There you are. This deflection spike of these two stars has what? 8 spikes, You have the 1, 2, 3, 4, 5, 6, the 6 hexagonal spike, and the 2 horizontal spike. So these 8 spikes will show that it is Webb telescope. Of course, this effect of deflection will not be seen for dim stars, let's say dimmer stars, but for bright stars you can see. So this star, God, top right hand corner, God, all God. Okay, so this is Webb. So basically it's an index catalog 348. All right, it's taken by our this is actually processed by our Professor Kevin Rudman, the professor of astronomy in Penn State University. All right, and also processed by our lady astronomer Catarina Alves de Oliveira. I think from the name you know is from Portugal, and is a scientist and manager at ESA. ESA is a European Space Agency. All right. the one in Kuru, Guyana, they have the launch center where they launch the James Webb, and she's the one who is involved in NIRSPEC. NIRSPEC is near infrared camera spectroscope for this what they call James Webb Space Telescope. All right. So basically, this is a big project. You have NASA, you have ESA, United States Agency, CSA, Canadian Space Agency, SCSCI, Space Telescope Science Institute that look after James Webb, Professor K. Lubman, Penn State University, and this Katerina Alves from ESA, right? So basically, this picture is of this young star cluster, all right? And then you see that, so basically from this information, because this is infrared, I'm very sure they will compare with the earlier data, and maybe if something interesting, they will work on it, and maybe we can earn a PhD from this just by looking at this object and studying it for 4-5 years. Remember, Bunwei, Marcus, in America, you do a PhD in astronomy. Let's say it's a good PhD, good university. It's about 4 to 5 years. So imagine studying this object, looking at the visible light picture from Hubble, looking at the infrared light from this Webb, and maybe from radio telescope, all add up together. You can do a PhD on this picture. IC 348. Index catalog 348. Okay. So the next one will be first of January. Okay, this is the last one, the 1st of January. Wonderful. So NGC 1232. NGC means New General Catalog. Actually, I always say New General Catalog doesn't mean that this catalog was just set up last year. No, it's very, very old, more than 100 years old. So by right, they should say OGC, or Old General Catalog, but they call it the old name still stuck with us. New General Catalog got many thousands of objects. This entry number 1232, a grand design spiral galaxy. And here the image credit is FORS, FORS. All right. So FORS stands for focal reducer and low dispersion spectrograph of the 8.2 meter VLT ANTU. Not HANTU, ANTU, ESO, European Space Observatory. Remember, in the northern part of Chile, called a place called Cerro Paranal Mountain, the Europeans have built the European Space Observatory. We have the famous VLT array telescope, very large telescope. They have the 4 main telescope and the other 4 smaller telescopes combined together. It's an optical telescope array. And the 4 main telescope got named, and named after a kind of native language Mapuche tribe people. So number 1 is ANTU. So basically, it's 8.2 meter means a single mirror 8.2 meter. All right. And then you have also what they call Yepal, Keyun, and so on. So these are the 4 mirrors there, and one of them, the ANTU, took this picture in visible light. All right. And this is, of course, they never say processed by who. So basically, this is actually from the data set of very large telescope. And remember, in astronomy, whenever you take any picture from Hubble Space Telescope, James Webb Space Telescope, from VLT, or any popular observatory in the world, the astronomer or the organization that took the picture has a copyright for only 1 year. That means if this is taken more than 1 year ago already, so now it's public property. You can use it. Okay, but if it's taken before 1 year earlier, you cannot publish it. But the scientists who took it, they can publish it. All right. So they have 1 year time frame. If they don't use it, then they put it out in the internet. We can use it, or we can claim that we can use it because more than 1 year. All right. So this is from this. And remember, nowadays the 4 very large telescopes in this what they call in Chile, they are about the maximum. I put here. I'll show you the size of the aperture, single mirror. You saw that? Oh dear, 8.2 meters, single piece of mirror. Whereas the Keck Observatory and the other big telescope are segmented mirror. Many segments, smaller ones joined together. But this is a single mirror. So now about the biggest type of optical telescope, single mirror is about 8 meter or a bit longer. So for example, the world's okay. So this is you cannot go make the mirror even bigger, because even bigger, the the mirror is so big. Let's say you have a 15-meter aperture, single mirror. It will be so big that the shape of the mirror will sag and the parabola will not be maintained, and you will never get good optics. So the maximum is our 8.2 meter. Of course, this 8.2 meter is not just 8.2 meter. At the bottom of the primary mirror, there are hundreds of actuator arms that will poke the bottom of the primary mirror to adjust it. Every second, this actuator will poke, hundreds of actuators will poke the back of the mirror many times, so that the shape of the mirror on top, the upper surface, is always a parabola. So this is what is called active optics. Right? And on top of that, the VLT uses active optics, which I mentioned earlier, and also uses adaptive optics. Adaptive optics means there's a way they can cancel out the turbulence of the air. Of course, we know that the air above the VLT in northern Chile is very dark, very clear, but you may have some turbulence. So you have used adaptive optics technology, you can cancel out the turbulence. So with active optics, with adaptive optics, very good. That's why I will tell a lot of Malaysians that when we look at the moon, you look at the Apollo landing site, with the active optics and adaptive optics of this large telescope, they can see the American footprint on the moon. Of course, the flag can see, the flag is much bigger than the footprint. All right, so that's it. So this is our grand design spiral galaxy by the very large telescope ANTU of the European Space Agency in northern Chile on the mountain of Cerro Paranal. Okay, so that's all for me for today. Then we'll wait. I'll go back to our group. So any final comments from us? One way, Marcus?
No from me.
Yeah. So for me is that I think this month, first month of January, our line made a good selection. Very nice, good selection. Okay?
We have a lot of cluster and
Very nice.
yeah.
And some of the trick shots are very nice. Next time we take a picture, I say, make sure you take the picture of the quarter moon and the quarter mountain. not bad, huh?
Yeah.
Marcus, any comment from you?
Sorry, Dojong.
Yeah?
There was an ink spill on my table. I'm cleaning up right now.
Okay. So wait. So have you recorded everything already?
Yeah.
Okay.
It's still recording right now.
I know. So let me comment. So do you have any comment on yourself other than the ink stain? Ink stain, of course, important lah. Any more comment other than the ink stain?
No comment.
Yeah. So thanks to everyone for the presentation. Boon Wei, Marcus, and thanks to Lai and of course Rayan also. Yeah. So,
Thank you, Dr. Chong.
so we'll meet, we'll present, we'll see again end of February. All right, end of February. So thank you, Boon Wei. Thank you, Marcus. So thank you, everyone.
Thank you
For watching. Thank you.